So the derivative of y equals e raised 5. That's a trick. If you use power rule, which states x raised n, if the function is x raised n, the derivative is n times x raised n minus 1. Yes? So one of the answers that I saw as I went around was y equals 5, y prime is equal to 5 e raised 4.
Technically, the real trick would have been using the exponential law that we had before, where it's e raised.
We're going somewhere. This is not right because e is not a variable unless otherwise stated in the problem. E is always a number. I need to.
It's a constant, isn't it?
E is a constant.
You said I should.
So that's not right. Another possibility was, y is equal to e raised x. So naturally, the derivative of that should be e raised x. So here we have e raised 5. The derivative of y prime should be e raised 5. And that's all. E raised 5 is a constant. What is the derivative of a constant? 0.
Wait, so then when would you use e raised n?
When there is an x.
So it has to
Oh,
be that.
not an number.
Not a number.
Oh,
I'm going to do this one. How do we find the derivative of y equals x squared plus square root of x plus 4? Yes.
We go in one term at a time.
Of course, we always do stuff one step at a time.
Well, no, what I mean is at the very least that we can apply the same law to square limits. Thus, we could do x squared first, then we deal with square root of x, and then we deal with plus 4. Plus 4 becoming 0. X squared at the very least, again, we use the x raised to the very least of power, and then that being n times x, and then I believe n minus 1 is the power of that. And then when it comes to the square root of x, what I believe it would do is you would actually. No, I might be wrong there, let me double check.
Okay, so x squared, we want to find the derivative of x squared, then square root of x, then the derivative of 4. That's easy. Yes. Now, that is a radical. Anytime you see a radical, the first step should be
To express it as basically a negative
1/2.
x raised 1/2.
Wait, right, not negative, I meant fraction, got it. Oh,
Derivative of x squared is 2x. Derivative of x raised 1/2. What happens to 1/2?
1/2 x. Goes in front of it, and then it becomes negative 1/2.
Decrease 1. What is 1/2 minus 1?
Negative 1/2.
Negative 1/2. Derivative of 4 is 0. If I move x raised negative 1/2 from the numerator to the denominator, it will become positive 1/2. Which I can rewrite it this way, do you agree? With the star, especially if you're going to go to calculus 2, differential equations and whatnot. When I teach the class, go derivative of this is that, and I get this look on the faces of students as if that's the first time they've seen this, right? You should know that the derivative of square root of x is 1/2 square root of x. Good. So we have x squared plus x cubed minus 4x divided by x squared. So how do we go about doing this? There is a term in the numerator, term in the denominator. If we have addition and subtraction, we can apply for each term. But if you have multiplication or division, you constantly apply the derivative for the numerator and the denominator. Yes.
Doesn't the x squared at the very least for each cancel out first?
Okay. So the very first step would be to split it up. What happens to x squared and x squared?
It's one.
X cubed over x squared.
That would just be x.
X over x squared.
It would seem to be 4 over x.
So all I did is I rewrote the function as y equals 1 plus x minus 4 over x. So we want to find the derivative. We know power rule works as x raised n, so I'm going to rewrite 4 over x as negative 4 multiplied by x raised negative 1. If that x moves from the denominator to the numerator, it becomes negative 1. What is the derivative of 1?
0.
0. Derivative of x? 1. What happens when I take the derivative of x raised negative 1? Negative 2.
0.
Oh, that, oh, my bad, you know?
Or x to negative.
What happens to that negative?
Because positive, sorry.
Okay. Negative 1, x raised negative 1, negative 1, negative 2. So negative times negative is positive. So I will have 1 plus 4 x raised negative 2. I don't like negative stuff, so I'm going to move it to the denominator. Good. Yes.
On the test, would we have to put it on the bottom or?
Most likely, yeah, this would be the answer. So here is another example for you to try. So I want you to combine what you learned in problem 2 with and that's in problem 3, put them together and see if you can find the derivative of that. Okay, so first thing to do, you can't directly take the derivative of the numerator and the derivative of the denominator separately. You just cannot. We will later talk about quotient rule and product rule, which will tell you how to take the derivative of the numerator if you have a function that is something over something else. In a problem like this, since I have a common denominator, I can split it up like the previous problem. Good. So root x and root x will get cancelled. That middle term is easy. 2 and 4 will get cancelled. So 2 over square root of x. I could rewrite square root of x as x raised 1/2, correct? So x raised 1/2. Could do the same thing over there. Good. What does this reduce to? It's all about the base. As long as the base is identical, what do you do? So base, same base.
You're not canceling.
So what happens?
X over
I can't
2.
simply get rid of the x.
X over 2.
X over 2, how did you get that?
Because there's exactly one difference between 1/2 and 3/2, so it's x to the 1 over 2.
So if you have identical bases, all you have to do is subtract the numerator power and the denominator power. In the sense you take away the denominator power from the numerator power. So 3 over 2 minus 1 over 2 plus 1/2. What happens to this term? Moves up. So 2 x raised negative 1/2. Good. X raised 3 over 2 minus 1 over 2, it's 2 over 2, which is 1. So x over 2 plus 1/2 plus 2 times x raised minus 1/2. Are we done yet? No. What we did thus far is simply rewrite the expression so we can use power rule. Most of you got to this part and got stuck right here. X over 2 is simply 1/2 multiplied by x. Yes, so you'll have plus 1/2 plus 2 times x raised minus 1 over 2. Good. When you take the derivative, if you have a number multiplied to a function, when you take the limit, that number stays as is, correct? So that 1/2 will remain as is. What is the derivative of x? 1. What is the derivative of 1/2? 0. What happens to that 2?
It's multiplied by -1/2.
Okay, so it stays as is. Negative 1/2 comes to the front. Decrease the power by 1. Negative 1/2 minus 1, negative 3 over 2. Good. So 1/2, 2 and 2 would get cancelled, minus x raised negative 3 over 2. Good. Good so far? Yes.
I'm sorry, how did you get negative 3 over 2?
Minus 1/2 minus 1. X raised negative 3 over 2 is simply x raised negative 3 over 2 divided by 1. Get rid of the negative thing, so 1/2 minus 1 over x raised 3 over 2. You can leave it as is, but there is another way to write it. Lewis wrote it. So half makes 6, yes, half.
1 over cube root of x. Right?
Cube root of
Yes, so
x.
3, the radical x.
So close. Lewis,
X squared, x cubed inside the square root.
so it is actually the square root of x cubed. So x raised 3 over 2, I can write it as x cubed raised 1/2, correct? So 3/2, 3 times 1/2, I get 3/2. So I could write the denominator as square root of x cubed. It's very likely MATLAB Plus may not accept that as an answer. I don't know. And on an exam, this is going to be the choice that you'll have. Good. So know how to go from there to there. X squared multiplied by x squared plus x plus 1. The most common mistake that students would make, state the derivative of x squared, which is 2x. Take the derivative of the second term, 2x. Derivative of x is 1, derivative of 1 is 0. Right? What I did is simply took the derivative of the first term, multiplied it to the derivative of the second term. Completely wrong.
What you gotta do is you first gotta solve this instead of parentheses, so parentheses 4.
Yes. So as long as you have terms in addition or subtraction, you can distribute the derivative. But if you have multiplication or division, you've got to wait until section 3.2. So here, distribute x squared. X squared times x squared is x raised 4. X squared times x, x raised 3. X squared times 1, x squared. Derivative of x raised 4, 4x raised 3. Derivative of x cubed, 3x squared, and 2x. The only person who is alive. What is your name? Tiffany. Oh, and Alan. How could we miss him? What's common in all three terms? X. X comes out of x cubed, what would we have? X squared. Second term, without x, 3x plus 2. Good. So this is the most common mistake. You'd move the 2 to the front. What? 3x plus 2, raise 2 minus 1, which is 1. Write the answer is 2 times 3x plus 2.
I think God's needs abomination.
Right? If that is the case, life would be quite easy. So, as I mentioned here, section 3.2, when we get to 3.2, it has order rule. Section 3.4, we have chain rule. So this problem would use chain rule. When we get to that, we will know. But how do we do it a complicated way? First, we've got to rewrite it. In other words, you FOIL. If you FOIL, you would get 9x squared plus 6x plus 12x plus 4. So all I did is I rewrote the function. Now I have to take the derivative. The derivative does not affect the constant, so it remains as is. Move the 2 to the front. Reduce the power, 2 minus 1 is 1, x raised 1, x. 12 remains as is. What is the derivative of x? 1. What is the derivative of 4?
0.
So it is 18x plus 12. Okay, so this part we can leave it as e raised x. Denominator, that's the third root of x, which simply means x raised 1/3 plus x squared. And you can move x raised 1/3 from the denominator to the numerator, x raised negative 1/3 plus x squared. What is the derivative of e raised x?
E raised x.
X raised negative 1/3. If you take the derivative, negative 1/3 moves to the front. X raised negative 1/3 minus 1. You know, as I went around, people just struggle trying to do this in their head or use the calculator and put it in a decimal. But the moment they wrote it out, it clicked. You have to find the common denominator, and they got the answer in a matter of 10 seconds. So don't be lazy, that's enough. So negative 4/3. And plus x squared. So if you can do it, you know, in your head, more power to you. But if you can't, just write it out. Yeah. So 2x. Yeah. 2x. So e raised x minus 1/3 x raised negative 4/3 plus 2x. The 3 is in the denominator. I can move x raised negative 4/3 from the numerator to the denominator.
Where you go.
It would become x raised positive 4/3 plus 2x. We can rewrite that in terms of a radical.
Where you would have 1/3 times at the very least side.
So x raised 4/3 is simply x raised 4 raised 1/3. We know if the if the exponent is 1/3, it would be the third root. So we will have e raised x minus 1/3, third root of x raised 4 plus 2x.
Cube root. And then that.
Good. So, long time ago, we found the equation of the tangent. We wanted to find the equation of the tangent line at 2,-4 for that function. And we got to that answer. How did we get to this answer?
Difference quotient.
We took the difference quotient, spent a lot of time, found this instantaneously. Then we used it in the equation of the line, finally got to the answer, negative 8x plus 12. But if I know the function, when I take f prime of x, I'm simply finding the instantaneous rate of that function for all values of x. What is the derivative of 4x? Derivative of negative 3. Good. So the derivative is 4 minus 6x. What does the derivative measure? It measures the instantaneous rate of change throughout the entire domain of that function. Good. So throughout the entire domain, the rate of change is defined by that line. Remember when we did difference quotient, I this problem using difference quotients, I tried really, really hard to draw lines along that parameter. And that line is simply 4 minus 6x. We have a point, so at 2, -4, f prime of 2 would simply be the instantaneous rate of change, which simply is the slope at exact slope at the point x is equal to 2. So plug it in, the derivative 4 minus 6 times 2, 4 minus 12, I get minus 8. And that is the slope we found last time using difference quotient, minus 8. Finding the y-intercept is easy. Last time we made use of the point slope form. I can use the slope intercept form this time because I know the slope already. So y would equal negative 8x plus b. I know the value of x, the point is negative 4. I know the value, I know the value of x, which is 2. I know the value of y at x is equal to 2, that would be negative 4. So negative 4 is equal to negative 8 times 2 plus b. Negative 4 would equal to negative 16 plus b. Move negative 16 to the other side, b would be negative 4 plus 16, which would imply b is 12. So the slope of our tangent line is negative 8 at that point, and its intercept is 12, so the equation is negative 8x plus 12. That's the answer we had last time. Does that make sense? So, given the choice of finding the equation of a tangent line at a single point using the difference quotient versus the derivative, which one would you use? Difference quotient. Clearly, this one. So the reason why we have derivatives is because this is just one tangent line for the function. Imagine finding the equation of the tangent line for this function at every single point of that function. We don't have time for that. And evaluating difference quotients are difficult, and as you go for functions other than polynomials, it becomes more difficult. So we have derivatives to save us. What is the derivative of x raised 4? What is the derivative of e raised 6? Now the point is 0, so at x is equal to 0. Zero cube, 0, 0 plus 0, 0, e raised 0, 1, you get 1. Anyone can find this number, but if you have to explain this to me, what would that 1 mean?
So it'd be the slope of the tangent line across all the domain.
It is the slope of the tangent line across the entire domain.
At 0.
just at zero, not across the entire domain.
Oh, well, I
This
missed
is an instantaneous slope, so that would be the slope of the tangent line at x is equal to 0. Now, the slope of the line is going to remain the same when you draw it. That's not going to change. But it's wrong to say that this will be the slope for that function on its entire domain, because that line is going to change back and forth as you go, as you put different values for x. So we know the slope. We can use the slope intercept form. When x is 0, y is 1. I know the slope m to be 1 at x is equal to 0. So 1 is equal to 1 times 0 plus b, which would mean b equals 1. So the slope is 1, the intercept is 1. This would imply the equation of the tangent line is y equals m, 1 times x plus b.